All right, in Unit 3, we're going to review some geometry, basically because you need a little geometry review for tax. So we're going to go through a couple days of that today. If you remember, the sum of the angles in a triangle is 180 degrees. And you have these notes, so you should be filling them out as we go. In triangle ABC, find the measures of angle 1 and angle 2. Well, knowing that the sum of the angles in a triangle are ABC, we can find out what this angle is. We'll call it angle theta. Okay, so 60 plus 40 plus x is equal to 180. So that's 100 plus x equals 180. And so x is equal to 80. Well, if you remember, if this is 80, we'll go ahead and write that in there. Take that off and write in that this is 80. Some things you need to remember about angles. Angle 1 and angle 2 are called vertical angles. Okay, they're vertical angles. And vertical angles are congruent. So angle 1 is equal to or congruent to angle 2. So that means we know that angle 1 is congruent to, go back. Angle 1 and angle 2 are linear, is a linear pair. I'm going to go back. Misspoke. I was thinking that what we found was angle 1. Angle 1 and angle 2 are a linear pair. So when we find out what angle 1 is, we know that angle 1 plus angle 2 is also going to equal to 180 because they're a linear pair. Now our angle, we're going to call this angle 3. Angle 3 then, and that's the one I was thinking I was referring to a while ago. Angle 3 and angle 1 are vertical angles. Okay, and vertical angles are congruent. So angle 1 is equal to 80. Okay, so that's one of our answers, and it's degrees. Since angle 1 and angle 2 are a linear pair, they form a line. If angle 1 is 80, angle 2 must be 100 degrees, or 180 minus 80. So that's how you would use that property of the fact that triangles angles add to be 180 degrees to find these exterior angles on this figure. What is the measure of angle E in this figure below? All the inside angles of a quadrilateral, okay, inside or interior angles of a quadrilateral, and I'm going to abbreviate quad, equal 360 degrees. Okay, so we know this symbol means 90, so we have 6x plus 8 plus 9x minus 10 plus 77 plus 90 are equal to 360. Okay, which is 15x plus 165 is equal to 360. That means when I subtract 165 from both sides, 15x is equal to 195, and x is equal then to 13. So angle E is 6x plus 8. So to get angle E, you're going to say the measure of angle E. You're going to say 6 times 13 plus 8 which is 78 plus 8, or 86 degrees. And that would be the measure of angle E right here. Okay. Now in figure 3, I'm going to move up. I'm going to click off of this. If you need to pause it to finish to catch up, you can pause it. But I'm going to click off this and move my paper up to see a couple more. Okay, go back to my pen. In this figure, BC is parallel to ED, so we're going to mark those with an arrow to show that those two are parallel. AE is perpendicular to ED, so we use our little right angle symbol to show that that's perpendicular. What is the measure of angle BAE? So it's this angle right here that we're looking for. Remember, A is the vertex of the angle, BAE. The measure of angle ABC right here is 110. Okay, so I've got all of that labeled. If BC is parallel to ED, then angle D, if these are parallel, then these angles are going to be the same. This line, if this is perpendicular, if this is a right angle, this is a right angle. Parallel lines cut by a transversal, those are same side interior angles, and same side interior are supplementary, so that means if this is 90, this is 90. There's a couple ways you could do that. The inside angles of a pentagon are the sum of the angles of a five-sided figure, it's 540. And if you remember that formula, it is, let's go back, and I clicked off and I messed up, had to stop for a minute. So let's go back. We decided that this was parallel to this, and parallel. This is a 90-degree angle. If this is 90 degrees, this is also 90 degrees. We can do this a couple ways, and this measure here is 110 degrees. All right, we know, if you remember, that interior angles, the sum of the interior angles of any polygon are 180 times n minus 2. So for a triangle or a three-sided polygon, the angle, the sum, and that the symbol for sum is usually a capital sigma, is 180 degrees. For a four-sided figure, it's 360 degrees. 4 minus 2 is 2 times 180. 5 minus 2 would be 3 times 180, which comes out to be 540 degrees. So if you can remember that, then that helps, because one way to solve this, then, method 1, if you know that, then we know all but angle that we're looking for, this one. So we have 110, said 110, wrote 100. So we have 110 plus 90 plus 90 plus 90 plus x is equal to 540. And so that would be the measure of angle A is our x, so I'll just write it, the measure of angle A, plus 380 equals 540. And if you subtract 380 from both sides, then the measure of angle A, or BAE, is 160 degrees. Okay. All right, so method 2, okay, method 2 is if we could draw a line AF parallel to BC. So we're going to draw this in here. Okay, and that's parallel, and we're going to label this F. So we're going to draw AF parallel to BC. Okay. The measure of angle AFC is 90. For the same reason that CDE was 90. Okay, and then if you remember that a quadrilateral is 360, you have the measure of angle A plus 110 plus 90 plus 90. Okay, is going to be, it should have been a plus, is going to be equal to 360. So this part of the angle, BAF, is equal to 70 degrees. Then we have to go through and find this part of the angle, which if this is 90, then so is this. So again, we have a quadrilateral. So we have the measure of angle EAD is equal to 90 plus 90 plus 90 for that angle plus that is equal to 360. Okay, subtract 270 from 360 and we find the angle EAD is equal to 90 degrees. And so the total is still 160 degrees for BAE, which is what we were asked to find. So the measure of angle BAE is 160 degrees. Okay. It's easier if you remember this formula for the sum of interior angles, but you may or may not know that. Okay, having a Pythagorean theorem on a right triangle. Remember that has to be a right triangle. C is always the longest side of the hypotenuse. We have a squared plus b squared equals c squared. Joey's in a hurry to get to the playground. If he cuts across the playground on the grass instead of this following the sidewalk, how many yards does he save? Round answer to the nearest yard. So 60 squared plus 70 squared is equal to c squared. That's 85, that's a 7. That's 8,500 is equal to c squared. Then we have to take the square root of both sides, and that's 92.195. And that's a C. Okay. Now, they want to know how much he would save. So that's not the answer. You have to remember, you have to answer the question. He would have walked 60 plus 70, or 130 yards. Subtract 92.195 from that, and that tells me how much he saved by cutting across. And that's going to equal 37.805. And the answer is to round it to the nearest yard, so it's going to be about 38 yards. Okay, it's using Pythagorean theorem on a right triangle. Okay, and the last problem, let's go to that for this set of notes, is what is the perimeter of the rectangle to the nearest foot? Well, we know the width, so we know that this is also 18. We know the diagonal, we have to figure out the length, and then we can find the perimeter of the rectangle. So you have a squared, which is the length, plus 18 squared is equal to 32 squared. So a squared is equal to 32 squared, which is 1,024, minus 18 squared, or 324. So a squared is 700. Square root that. So a is 26.758. Now perimeter formula is 2 times the width plus 2 times the length. So we have 2 times 18 plus 2 times 26.758. And that comes out to be 88.916. And the instructions are rounding it to the nearest foot, so that's going to be about 89 feet. And that's the answer to that one. All right, we're going to start pretty quickly on day 2 of triangles.